Okay, so today what are we learning about? We're going to learn how to compare the rates of change at 2 points using the average rate of change, and we're going to start to touch in on the second one, how two quantities vary together at different points and how on different intervals of a function. Just meaning we might be looking at intervals that are 1 apart and the intervals that are 2 apart and stuff like that. So we're looking at average rate of change. What's a synonym for average rate of change? Not same. Slope. Slope is the same thing as average rate of change. Now, why don't we use the word? Slope is for a line. Average rate of change doesn't have to be a line. It can be a curve, but you're still measuring the slope on that curve. Okay? Starting off here, we have some vocabulary. I'm going to skip that slide. So the first thing we're going to talk about is average rate of change, and I'm going to give you a formula for this in a second. The average rate of change, you're going to see me write it this way all the time. AROC. What do you think AROC stands for? Average rate of change. If you remember from Algebra 1, it's calculated by doing the change of y's divided by the change of x's. Now, I just wrote in there some math symbols. I'm speaking English, but I'm writing in math. Some of you can speak English, can write in Spanish. I'm speaking English, I'm writing in math. That says the change in y's divided by the change in x's. You could have written it this way in Algebra 1. Y2 minus y1 over x2 minus x1. That's how you calculate. Goodness, squeaking all over the place. That's how you calculate your slope or your average rate of change. Now, there's some examples down here that you could read through. I filled in the notes for you, so these are just reading in case you're going back over it later. I'm going to go through the math and explain as I go on. Here is the math way of writing out what I said here, the change of y over the change of x. They're using this function notation. They're plugging in the letter b and a. Now, I want you to note here that a is smaller than b. So when you look at this formula, it says you're taking, if you look on the denominator here, you're taking the larger x value and subtracting the smaller x value. And the numerator, it'll be the y value that occurs at b minus the y value that occurs at a. That's what that's come from. You can write it that way, or you can think of it as the change in y's divided by the change in x's. Okay? Something I want to show you. It's called a secant line. What is a secant line? A secant line is a line that connects 2 points on a curve. I'm going to say that again. A secant line is a line that connects 2 points on a curve. So a line. Show me a line with your arm. What does a line look like? Now show me a curve with your arm and hand. What's the difference? It's not straight. A line is straight. A curve is curved. Okay, so here on our, let me use this. We have a secant line we can add in. Use your ID, and we're going to add a secant line to this curve. Here is a secant line I'm going to add to this curve. A secant line is a line that goes through and intersects a curve at least 2 times. It can intersect more than 2 times, but it must intersect at least 2 times. That is a secant line. A secant line will intersect a curve at least 2 times. So I'm going to write the word here, secant. That is a secant line. You would calculate the slope of that secant line doing that formula. Change in y's over change in x's. So that ought to complete that part of the notes. Let's start now looking at some mathematical examples. You might hear me say tangent line. Later we'll have a tangent line as well. It's going to be a little bit different, but they're very much related. Okay, did everybody grab a calculator? All right, great. It says find the average rate of change of f of x equals negative 2x squared plus 4x plus 6 on the interval negative 3 to negative 1. Draw a secant line on the curve to verify your answer. So I'm first going to do this only by hand, and then after, for a lot of today, we're going to just use the calculator to help us out in these values. But I'm going to first do it purely by hand. So here, I want you to list under the numbers, which one's smaller, -3 or 1? Okay, put A there, and this is B. So if we use our formula from the previous slide, it said AROC. What did AROC stand for? Was the change in y divided by the change in x, is also shown as f of b. Now, what is our b? -1. So put f -1 parentheses minus f -3. Let me write a little larger here. Sorry. Over. It was b minus a. Which one's our b? -1 minus -3. I'll put that in parentheses because it's double up of negatives. All right. What is f -1? I don't know. Let's calculate that. I'm going to come over here to the side. What is f of -1? To calculate, you substitute -1 anytime you see an x, and you substitute into parentheses. So I'm going to substitute this into this equation from right here. Here's f of x. I'm going to substitute. So -2 times -1 quantity squared. That means when I say quantity, I mean inside of our parentheses. The -1 is going to be inside of parentheses being squared. Plus, now what do I do? 4 times -1. Again, I'm going to put that -1 in parentheses. You want to make sure you don't have a calculator error, use a parentheses. Plus 6. Now, we could use mental math. Could use a calculator. I'm going to do mental math first. PEMDAS says we got to square the -1 first. PEMDAS is order operations. You look for parentheses. Can't do anything inside the parentheses. Second, you look for an exponent. I have an exponent. What's -1 times -1? Okay, so this will be -2 times a +1 plus, what is 4 times -1? -4. So I'm going to erase that plus and change it to a negative. 4 plus 6. Okay, let's simplify one more time. What's -2 times 1? -2. I agree. Minus 4 more. -6. Add 6. 0. That means f of -1 is 0. F -1 is 0. Now let's find out what f of -3 is. F -3. Again, I'm going to substitute all through the equation. So we have -2 times -3 squared. Is that it? Do I just have to simplify that?
Plus
Plus
4 -3
well, I forgot the 4. 4 times -3. Good, Carlos?
plus 6.
Plus 6. Okay, PEMDAS, we got to square -3 first. What's -3 times -3? +9. I'm going to rewrite that part. -2 times 9. What's 4 times -3? -12 here. Plus 6. Let's reduce this one more time. -2 times 9. -18. Minus 12 more. -30. Add 6. -24. Minus the -24. And this will be -1. What happens to a minus of a negative? Plus. So it becomes -1 plus 3. So we're going to simplify this. 0 minus a -24. +24. -1 plus 3. 2. 24 divided by 2. We have our answer. Once we simplify that, 12. Our average rate of change is 12. So that's doing it all using algebra. That was fun, wasn't it? Now I'm going to draw the secant line on part B because we're going to use a little calculator here in a second to make this one work, okay? So now I've asked everybody to get a calculator. I'm going to show you a calculator trick on how to do these problems so you don't have to do all the algebra every time like that. On the calculator, go to part B, and we're going to type this equation in. So let me open up my calculator. I'm going to go to the home screen just to clear out everything I got. Oh, my calculator's frozen. Sorry, hang on. Weird. I can type in, but I can't click anything here. Let me try it one more time. There we go. Never mind. Well, my calculator doesn't seem to be cooperating with me. Not good. All right, well, I'll have to restart mine. I'm going to do this by hand, and I'll have to show you later on how to use the calculator. So we won't do it yet. Let me go to, sorry, got to force quit this. And in a moment, I'll show you how to do this by hand. By calculator. So let's do this one again. All right, so remember our formula? What was our formula? What's the simplified version? Change of y divided by change of x. Okay, so what I'm going to first do is find f of what value? F of a? B. So let's find f negative 1 first. How would I find f of negative 1? I would take negative 3, parentheses, negative 1, cube it.
Plus 2, parentheses, negative 1.
Perfect.
Plus 3.
Okay. So negative 1 times negative 1 times negative 1. It's negative 1. And then you multiply that times negative 3. Okay, we get positive 3 there. Positive 2 times negative 1. Minus 2. Plus 3 more. So 3 minus 2. 1. Add 3. 4. So f of negative 1 is 4. Okay, now let's come back and let's find f of a. So f of negative 2. So basically the same calculation, except anywhere we see negative 1, we're going to replace with a negative 2. All right, negative 2 cubed. So negative 2 times negative 2 times negative 2. It is negative 8. 3 negatives make negative. 2 times 2 times 2 is 8. Times negative 3. That's positive 24. 2 times negative 2. Minus 4. Plus 3. Okay. What is 24 minus 4? 20 add 3. 23. So our formula here for the AROC is change of y's. So we have 4 minus 23 over the change in x's. Negative 2 minus, negative 1 minus a negative 2. What is 4 minus 23? Negative 19, good. And a minus of a negative is a positive. So what's negative 1 plus 2? 1. Negative 19 divided by 1. I've got negative 19. That would be our average rate of change. Now, because my other calculator hasn't loaded back up, I'm going to switch over to Desmos. It's always great to have more than one plan here. So this is going to be pretty cool when you see it. Let me open up here a Desmos graph. If you wouldn't mind, can you read off to me what was our original equation?
Plus 2x plus 3.
Oh, clicked. Sorry. Plus 2x plus 3?
Yes.
That was our equation. Now we found the secant line between, so the slope is negative 19. So there's a line with a slope of negative 19. Now we wanted to go between what 2 points? Do you remember? Oh, it's right here. Negative 2 and 1. Because I know a trick on how to graph this line, what I'm going to do is I'm going to make this graph go through the point at negative 2. So what I'm going to do here on the x is you're going to learn later on that x is always a liar. Instead of putting in the negative 2, what I'm going to do in parentheses is I'm going to say x plus 2. And then on the y's, I'm going to just make it a liar as well over here. What was f of negative 2? 23? I'm going to put a 23. You don't need to know what I'm doing. I'm just telling you. I'm going to put a negative 23. So what just happened? On my calculator, do you see how the blue line intersects the red graph at negative 1? And we're also supposed to intersect at negative 2. Let me make this a little bit bigger so it's easier to see. Let me shrink my x values here, my table, to negative 5 to positive 5. Here's what we just created. We created a tangent line. A tangent line, if you remember what I said, it's a straight line that goes through a curved graph at least 2 times. Check out the blue line we created. The slope of the blue line is negative 19. That's what we solved for. It is a secant line. So this blue line is a secant line because it's a straight line that goes through the red curve. Now, where is it hitting the red curve? What are the x values? Negative 2 and negative 1. Now, that's where the points we found for. So what we just solved for is what is the average slope between negative 2 and negative 1 on this graph? And we found the average slope is, what's the average slope? Negative 19. So the original graph, was it a straight line? No, so the slope was changing. We found out what the average slope is. What's the average slope between negative 2 and negative 1? Negative 19. That's why that straight line hits it. Now that's what I was trying to show you on the last one as well. If my calculator's up, I'll also show you how we can find the values faster. Let's see if it's loaded yet. Ah, it is. All right. So in the next problem, we'll get to use the calculator. So let's look over here this time. Part C. Given the table, find the average rate of change in simplest form of the function over the interval 3 to 4. So what are these two values, 3 and 4? What do they represent in this problem? From the formula, is it f of A, f of B, A, B? What values are 3 and 4 representing? This is A and B. This is A, this is B. So what we're focusing on is over here. If this is A and this is B, what does that make 29? I'll give you a hint. Look at the column title right up here. This would be f of A, and what's this one? F of B. So in this problem, they've done all the work for us. All we have to do is simplify the values. They've given us all of our numbers to plug in. So what's the average rate of change formula again? Change in y over change in x. Now here's the deal. It actually doesn't matter which order you go in as long as you stay consistent. Meaning, you could do A first, B second, but you would need to do, if you did that, f of A first, f of B second. I still like doing B minus A because then you have a positive number in the denominator. So I'm going to do B minus A. 4 minus 3. Now if I do 4 minus 3, I have to do which one? 29 minus 32 or 32 minus 29?
32 minus 29.
32 minus 29. You have to go in the same order. Let's simplify. What is 32 minus 29? 3. And 4 minus 3? 1. So what is our AROC? 3. Said another way, the slope of this curve between 3 and the x values, the interval 3 to 4, the slope would be an average of 3. A straight line secant with a slope of 3 that intersect the 2 points perfectly. That's what that means, what we just solved for. All right, we have another graph. What is that? A secant line or a curve? Curve. It says the function is shown. What is the average rate of change? Also known as, how can we think of average rate of change? Slope. We want to know what's the average slope of the curve between 0 and 3. So come to your graph. I'm going to let you do it first. Put a bigger dot where x value of 0. Put a bigger dot on the value of x equals 0 on the graph. Okay. I'm getting this point right there. Is that where x is 0? Okay, put another dot where x equals 3. Where the function has an x value of 3. Where would this dot be? I'm getting right there. We want to know what's the slope between those 2 points. What's the average rate of change? Which will end up becoming, let's see if I do this right, a secant line. And it looks like I just slightly missed. Let me fix my secant line. That's better. That's what we're trying to get to, a secant line. So what's the slope here? If you look at the graph, remember it's change of y's over the change of x's. This is for your AROC. How much do my y's change? What's my y value at point B? At an x value of 3. What's my y value there? 0. So it's 0 minus, what's my y value at f of 0? Negative 15. Good. What is my, the end of my interval? What is the x value at the end of the interval? 3. And what's my x value at the beginning of the interval? 0. 0 minus a negative 15. That's positive 15. And 3 minus 0? 3. What's our AROC this time? 5. Good. Average rate of change is 5. And you know what? I should have been doing on all of these is on the interval. You could say between 0 is less than or equal to x, less than or equal to 3. I should be saying the interval each time because the slope would be different on different intervals. The average rate of change between 0 is less than or equal to x, which is less than or equal to 3, would be 5. I should have been including that on all of them if you wanted to be precisely correct. I'll wait for that. Use the word between. You can also say on the interval. So on all these previous questions, I should have included that on there. I'm going to go ahead and do that now. So go ahead and add this on. Average rate of change. Or you could say 4. I'm going to use 4 because it's just a smaller word. 4. 3 is less than or equal to x, which is less than or equal to 4. So add that on. We're going to make the notes perfect here. And going back here, this average rate of change was negative 19 between what 2 points? Okay. And on part A, our average rate of change was 12. I never even circled this one up. Negative 3 to 1. All right. So average rate of change. What's another synonym we could think of with average rate of change? Slope. If the average rate of change is increasing, if your average rate of change is increasing, what does that tell you about the graph? Concave up, very good. Your average rate of change is decreasing, it's concave down. If your average rate of change is positive, nope, not necessarily concave up. Doesn't really mean much at all. Your concave, if it's positive, doesn't matter much. If it's negative, doesn't matter much. What does matter is it increasing or is it decreasing when it comes to concavity? Okay, let's see, where are we now? Your turn. I'm gonna let you think on this one. Okay, hopefully that was enough time. On which interval is the average rate of change the slowest? Here's what I'm gonna do. I'm gonna do a countdown. I want to put up answers. If you think it's A, put up a 1. If you think it's B, put up a 2. 3 is C, 4 is D. My last class was totally split, so I'm curious to see what you do. That's why I want the number, so I can see around the room. Ready? Everyone understand what's gonna happen? I need complete participation. 5, 4, 3, 2, 1. I'm looking around. I'm seeing a lot of fingers overall, mostly either 3 or 4s. So, okay, you put your fingers down. To find the answer, by the way, make sure y'all vote back there in the corner. To find the answer, you're looking for which interval is the slope the smallest. So show me with your arm, what would a great slope look like? If the slope was really great, what would it look like? Show me with your arm. You should be going really close to being vertical. So what would a small look like? Now if you go here, this means 0, but there's actually something smaller than 0. What's smaller than 0? Negative. So honestly, you first look for a negative slope. Do we have any negative slopes? No, so it's only positive slopes. So you're looking for the one that's most flat. Which interval is most flat? 10 to 29. That one right there would be the most flat. This is the smallest slope. Smallest slope. Different question. Which one would be the greatest? 2 to 3. This interval would be the greatest slope. Questions over that? Okay, I have another one for you to try. I'll let you look at this one. I'm going to pause the video and I'll pick back up in a second. All right, let's take a look at this. So the formula is the change in x's divided by the change in y's, true or false? Change in x's divided by change in y's? False. What is the formula? Change in y's divided by change in x. Here's what I'm going to do. I'm going to write it like this. What's the change in y's going from 8 to 56? What's 56 minus 8? 48. If you haven't put 48 there, and it increases by 48. So I'll do plus 48. What about the change from 56 to 100? Okay, and it increases, so I'll do plus 44. What about the change from 100 to 149? It increases by 49. And from 149 to 201, 52. So the biggest number up there is obviously 52. So does that mean the answer is from 41 to 52? No. Why not?
Because the x, it increases the x.
You have to divide by the x's. So what's this x increased by?
3.
This is increase of 3. What about here? 11. What about here? 20. And finally, 11. So you have to divide. What is 48 divided by this one right here? Would be 48 divided by 3. I did squiggly. I shouldn't have. It is exactly 16. I didn't need to do approximately. That's answer choice A. Okay, B would be 44 divided by Wait, that's 21 to 41. I'm sorry. Sorry. Scratch that. What's B? It's how much we increase going from 21 to 41? Wasn't 44. How much we increase going from 21 to 41 on the Y's? 49. This one should be 49 divided by 20. 49 divided by 20 is approximately 2.45. 2.45, okay? C, from 10 to 21. What do we increase going from 10 to 21? How much does our Y's increase? 44. How much does our X increase? 11. 44 divided by 11 is 4. And finally, from 41 to 52, how much does our Y's increase by? 52. And our Y's increased by 11. That is approximately
4.72.
4 point what?
72.
72? 4.72 here. Okay, so which one has the greatest slope? Average rate of change, I should say. A. So remember, it's change of Y's divided by change of X's. That's how you go about that problem. All right, how about one more here? The function h of t equals 10 square root of t gives the height of the function, height in feet of a hot air balloon after t seconds. Find the average rate change from t equals 1 to t equals 9. Interpret the results. All right, time to show you how to use my calculator. So go to my calculator. And I want you to press, no, it's still not working. Well, I'm not sure what's going on with that. That is just frustrating. Well, I'll show you on Desmos. You can use my calculator to do basically the same thing, but I want to do it on Desmos here. I'm going to type in the function. The function was h of t equals what? Ten square root, come on, square root button, t. Now what I'm going to do is hit the setting here, edit list, and it says create a table. So I'm going to do that. And we want to find two values in particular, 1 and 9. So I want 1 and I want 9. Now here's the values that matter to us. Here, so we're going to write those down. You have them written down on your paper? So in the X column, 1 and 9, and the Y column, or the H of T column, you'd have a 10 and a 30. So I'm going to write those down. I'm going to change the variables. I'm going to change the variables back. So here's how it should look. In the T column, we have 1 and 9. And in the H of T column, if you plug in a 1, what's the square root of 1? What's the square root of 1? 1 multiplied by 10. We had a 10. And then when you plugged in a 9, what's the square root of 9? 3. Multiply that times 10. 30. Okay, so we have that. Now here's what I want to do. What's the change in Y's? How much do we increase Y going from 10 to 30? 20. And how much do we increase by over here? So my average rate of change would be 20 divided by 8. That was 30 minus 10 is 20. 9 minus 1 is 8. Can 20 divided by 8 be reduced? Yeah. What number goes into both 20 and 8? 2 it does, but 4 is bigger and does. 4 goes into 20 how many times? And 4 goes into 8 how many times? 2 times, or you could say 2.5. Here's what that means. On average, so that's an average rate of change. The let me say, sorry, the height. Here, I'm interpreting the result. Here's what I'm doing. The height of the hot air balloon increases 2.5. What unit are we in? Feet? Yeah. Increases 2.5 feet per second. And I forgot the word on average. Oh my goodness. On average. Sorry. The height of the hot air balloon increases on average 2.5 feet per second from T equals, or you can do it this way. I'm going to write it the other way, what we were doing earlier. 1 less than or equal to T, which is less than or equal to 9. That's the interpreted result. When your average rate of change is 2.5, that means for every 1 unit, you increase 2.5. Because our units were height and time in seconds, it increases on average 2.5 feet per 1 second. Now, this is only from 1 to 9. Would it continue to increase at the same rate forever and ever and ever? I mean, could a hot air balloon go out and leave the atmosphere? No, at some point in time, you're going to run into some problems if you're trying to fly a hot air balloon outside. So this is just saying between 1 second and 9 seconds, it's increasing on average 2.5 feet. Now, it's on average because it's the average rate of change. So have you gotten down average rate of change? The average rate of change can create some type of line. It's the slope of some type of line. What type of line does the average rate of change create? A secant line. It creates a secant line. A secant line is a line that cuts through the graph, intersects a graph or curve at least 2 times, at a minimum 2 times. Okay, phones up, please. Thank you. All right, let's switch gears. Concavity and the rate of change. Concavity is systematically exploring the rate of change of the function. So if we are concave up, what is that telling you about the average rate of change if it's concave up? It's always increasing. It's not a constant number. It's going to constantly be getting bigger and bigger and bigger. What if it's concave down? It's constantly decreasing. That's right. So the rate of change is talking about how independent, dependent variables work together. Concavity is telling you about the average rate of change, how those work. Okay? So here, the table gives the temperature in Baltimore, Maryland on July 5th, 2022. The independent variable is the number of hours since midnight, and the dependent variable is the temperature in degrees Fahrenheit. In what way does the temperature change between 6 a.m. and 9 a.m.? So go to your graph, and I want you to connect 6 to 9 a.m. Go to your graph, connect those points. 6 to 9. Now, connect it with the secant line. It means just connect it with the straight line between 6 and 9. Now, what happens to the temperature between 6 and 9? It increases by 1. Now, what happens to the time between 6 and 9? So, on average, how many degrees is the temperature increasing between 6 and 9 on average per hour? 1/3. So, you could say, on average, I'm going to put on average first so I don't forget that word this time. On average, the temperature in Baltimore increases 1 degree, 1/3 degree Fahrenheit per hour. And it's per hour, it's not per minute. If you remember, it's 6 a.m. to 9 a.m. It increases 1/3 of a degree per hour between what time? 6, which is less than or equal to x, which is less than or equal to 9. Or if you wanted to just use, say, 6 a.m., between 6 a.m. and 9 a.m. Now, to tie in the concavity, what happens next? I know we don't have to do it, but what happens next between these 2 points? Does the slope stay constant? What happens to the slope? It increases. So if the slope increases, is it concave up or concave down? At this moment, it's concave up. Now, here, it's hard to tell if that's increasing, decreasing, what. But once you come over here, what's happening? It's decreasing. So it's changed from concave up to concave down. Somewhere in between, it changes from concave up to concave down. Good. I'm going to move that so we're not confused later on the notes. All right. Part B. How are you? Let's look at now. Same graph. I want you this time to find the average rate of change for, is it 3 others? Yep. I want you to find the average rate of change for these 3 different intervals. This is not an A, B, or C, which one's correct type problem. This is calculate the slope from 9 to 11, from 11 to 12, from 12 to 17. Calculate the average rate of change for each interval. That's what this is, okay? So I'm going to give you time, and I'll walk the room here to check on you. All right, what did you find out between 9 and 11? 9 and 11, what was the change in y between 9 and 11?
+4.
Plus 4, and the change in the x's?
2.
Plus 2. So for here, the average rate of change would be 4 over 2, which is reduced to become 2. Good. All right, what about 11 and 12?
3 over
It goes up 3. And here?
1.
1. So the average rate of change
3 over
is 3 over 1, which is equal to 3. Great. And finally, this one. How much does it increase here? Or it decreases? Goes down to 8. And for how much time?
5.
Okay, so here it's equal -8 divided by 5.
Which is -1.6.
Good. Okay, so tell me, the average rate of change, it increases here. We had an increase. Concave up. Why is this concave up? Because the rate of change is increasing. Good. What about from here to here? We know it's concave down. Why? It would have to be concave down in there because the rate of change decreased. Very good. Making sense? Starting to connect some of those dots from earlier in the bell ringer? Okay. All right. Here's the note. Positive rate of change does not mean the temperature is increasing the whole time, or a negative change. I'll give you an example right now. It's been hot as fire outside. What has it been, like 105 basically every day? Okay, you could take the temperature at, let's say, try to think, make sure I don't do this example wrong. You could take the temperature at 11 o'clock in the morning. And then you can take the temperature the next morning at 4 a.m. What do you think if they're reading at 11 a.m. on one day versus the 4 a.m. the next day? Which one's going to be hotter? The 11. So does that mean that the temperature decreased the entire time from 11 a.m. to the next 4 a.m.? Could it have gone up first and then decreased? Yes. So this is just pointing out, when you do average rate of change, it's going to look like what shape when you do average rate of change? What shape was it earlier I was adding? It looks like a line. Average rate of change looks like a line. Does that mean the actual graph is a line? No, it could be a curve with other things happening. It could be curve, part of it increasing, part of it decreasing, but it could be a curve. So just remember, average rate of change is going to look like what shape? A line. We'll have some type of constant slope, whereas the actual function may be curve. That's what that note is talking about, okay? So don't miss that. Okay, so now let's compare the average rate of changes. This over here, I want you to write secant. This is a secant line on the left. Why is this a secant line? Because there's a curve being connected by a line. It's hitting how many points? 2. Okay, look at the next graph. Same curve between P and Q, but what's different this time? How about the line? It's only hitting once. This is called a tangent line. Write the word tangent on this one. Tangent. That's a tangent line. So the tangent line is calculated by what we call IROC, where what did AROC stand for? Average rate of change. IROC is instantaneous rate of change, meaning we want to get this as close to 1 unit as possible. Now this is really frustrating. My calculator is not working. Should say a prayer before I try to open it one more time. But I really want to show you this on the calculator, and it's just not cooperating for whatever reason. Maybe we'll get lucky. I'll have to use Desmos, and that won't be nearly as pleasant. But let's talk about the instantaneous rate of change. So here, for this function, estimate the instantaneous rate of change. So here's how we're going to do this. On your calculator, please work. No, it doesn't. Okay, on your calculator, I want you to add a graph. Because I'm gonna just try split screening this. I want you to add a graph, and on the graph, the first thing I want you to do is type in this equation. F of x equals 6x squared minus 1. Yours will actually say F1, if I remember right. Because in your calculator, if you did a new document, it'll say F1 of x. Type in 6x squared minus 4. On mine, I'll go ahead and type in F1 of x just so it looks like yours. And what I wanted you to do is find the instantaneous rate of change at x equals 4. So how do we do that? Am I going too fast, or do you have that typed in?
Use the table.
We're going to use the table. Press enter on your graph so that you see the graph. Now, for you to get a table, you press Control-T. This is weird. You're just going to have to listen to me. I'm going to do here by editing and creating this table. On your table, did you press Control-T and have a table now? Press the menu button. When you press menu, it has 2 options. I don't remember what the first one is, but I know the second one says table. Click table. I'm sorry, you have to just listen to me talk you through it, but that's what I have to do today. When you press table, is there an edit table settings number 5?
Yes.
Click that. It's first going to ask you where to start the table. What do you think you should choose? What does it say to look at? 4. Put a 4 there. Now for instantaneous rate of change, until we get to calculus, it's going to be hard to figure out what this is exactly. In calculus, it's very easy, but we're not there yet. What we're going to do is change the table step, what it's counting by. Right now, the tables by default count 1 unit at a time. I want you to change it to 0.1. Where it says table step, do 0.1. Then press enter. Once you do that, it should show you a table starting at 4, and it'll have 4, 4.1, 4.2. Are y'all seeing those values?
Yes.
Press the up arrow twice to where you also see 3.8 and 3.9. Now, is your table exactly the same as mine? Hopefully. All right, we're going to find the instantaneous rate of change. I'll show you 2 different ways of doing this. So 1, the long way, well, maybe I shouldn't have done this now. My computer seems to be panicking on me because I tried to put that image in there. 1 is we could do what we've been doing before, where we could take 2 values, and I would just take the value 4.1 and subtract 3.9. This would be a more accurate, but we can also use the calculator to do this for us. That's what I want you to do now. Press Control-Dock. It should get you a brand new page. Press Control-Dock, and I want you to choose to add a calculator. Control Doc should get you a brand new page. I don't know what I did there. Let me see. There we go. I fixed it, I think. Well, maybe not. When you have a new doc, here's what I want you to type in. Type in F1 parentheses 4.1. Type in 4.1 on your calculator. Don't press enter. Minus. Oh, wait. Before you press minus, you're going to have to hit control divide. It'll get control divide will give you a fraction line. Minus F1 parentheses 3.9 over 4.1 minus 3.9. Type that in and see if you get the same values. I'm sorry, this is small. Let me try to get a little bit bigger. There we go. When you type that in, press enter, see if it gives you 48.
Yes.
You getting 48? What that's telling you is not a secant line, but a tangent line. If you wanted to have a line that would go through the graph and hit only one location, not multiple, but one location, the slope would need to be 48 at x equals 4. If you got the same value as me. Did you hit Control Doc, got a new page, were able to type that in? How many people are actually getting that? I know I heard one very confident yes. Ooh, it's less than half the people in the room. This is really unfortunate. I can't use my Desmos or my calculator for whatever reason. Let me show you on my picture while you try to figure it out. You can ask the student next to you. Try to help it out. Let me show you on my picture what this means for us. On my picture, this is saying at x equals 4. Here's x equals 4. Let me zoom out. Still can't see it. Let me edit my settings. I want to go taller. Let's go 200. We want to find out at x equals 4 what type of slope this would have. We just found out that the slope would be 48. At x equals 4, x is a liar, so I'm going to put x minus 4. We know at 4 it's supposed to be up at 92, so I'll do plus 92. Now notice, here's a slope of 48. Here's x equals 4 right there. Tell me about that black line. Does it look like a secant line here? I want to ask that again. Think about it earlier. Does that look like a secant line? No. What did a secant line do? Intersected it at least 2 times. Does this intersect it 2 times? No. How many times did it hit it? Just once. That's what we mean by instantaneous. It's such a perfect one. It only goes through like 1 time like that. That's instantaneous. So what's the difference between average and instantaneous? Average creates what type of line? A secant. Instantaneous creates a tangent. Instantaneous is more accurate, but it's harder to figure out without calculus. We were using all those decimals. I was using a calculator, okay? So let me just see one more time if it'll let me throw that picture in. Hopefully it will. I have my doubts. Well, not looking good. All right, so let's go to the next one. Let's try this one. Let me get my calculator back out. Oh, no. I'm messing up everything. All right, y'all are going to have to just call out. Let's go new document, home screen. Go home screen, new document. It'll ask you to save. Click no. Select add a calculator. What is our equation this time? I can't see it. I can't change my window either now.
-2x
To the power 4.
plus x power 2 minus 3x plus 1 at x equals 1.
At x equals 1. Okay, so first graph that in. This time we're not even going to mess with the table. So after you type that equation in, press Control Doc to get a new tab. Once you get a new tab, I want you to type in the formula again. It's F. And yours will say F1. Let me put mine with the 1 so you can type in the same thing. You'll type in F1 of, what was the first X value we're looking for? Or what's the X value we're looking for? 1? So I want to do 1.1. I'm going to do just a tenth larger than 1 for the instantaneous. Minus F1, and I'm going to do a tenth smaller. So it's 0.9. If you don't know, you can do it this way. 1 point minus 0.1, and this could be 1 plus 0.1. You can do it that way if you wanted to. So I'm doing just a tenth bigger than 1 and a tenth smaller than 1, which I will reduce now. That's 1.1, and this is 0.9. In the denominator, do 1.1 minus 0.9. That's the instantaneous rate of change. That is your IROC. Your instantaneous rate of change is negative 9.8. So what is that telling us? At negative 1, what's our slope? That's right. Let me show it to you. Negative 9.08 is the slope at 1. I need to find out what is f of 1. Negative 3. Okay, so that means at 1, I'm zoomed out a little bit. You can see there it is at 1. This graph, change my settings. I don't need my x's to be so wide. Make it more narrow so you can see this clearer. And I want to make this, oops, not that low. Okay, you see what we just created? One more time. What did that just create right here? What type of line is that? The tangent or the secant line? The tangent line. So what happened is the smaller you make the interval, the more you make a tangent line. So if our interval gets really small, which in our case we use 1/10, we get a tangent line. Earlier we were doing a bigger interval. Sometimes 1 unit, sometimes 3 units. One of them, I remember was time 1 to time 9 seconds. That was an 8-second interval. The bigger the interval, what type of line will it create? A secant. The smaller the interval, what type of line will it create? Tangent. I'm going to make sure we got this down because you need to know it. The smaller the interval, what type of line will it create? Tangent. Tangent for instantaneous. The larger the interval, what type will it create? Secant. Either way, a tangent or a secant. What shape is a tangent or a secant? It is always a straight line. This is to measure the rate of change on not a straight line, but a curve. So it takes the curve and it finds the slope at 1 point. All right. Sorry about all the technology errors. It's been frustrating, to say the least. But here, the answer would be negative 9.08. If you want to write that down, make sure you have that on this one. The IROC. What does IROC stand for? That's right, was negative 9.08. And remind me, what was our IROC here? 48? That's exactly right. That's exactly what's happening. Yep. Okay. Now, I want to make sure, because of all this technology, I slowed down. What do we have left here? 1, 2, 3. Oh, just 3. Oh, perfect. Okay, we want to determine to see which one has the greater instantaneous rate of change. Now, we can look at the graph. It says check the graph to confirm. We can plug in our numbers, though. So we're going to first do this with our table. Or not our table. We're like the way I've been showing you. We're going to create the numbers, and then we'll check the graph and make sure it's accurate. Okay, so first, let's graph the equation. So go back to your calculator, clear everything out. So home screen, new document. Choose not to save. Go add a graph. You should see f1 of x. What's our equation this time? X squared plus 3x minus 4. Okay, we want to know at x equals 0 and x equals 1. And what type of instantaneous or average rate of change? Instantaneous. So now press Control-Dock to get a new page. The formula, you want to do Control Divide first. F1 of, let's find it at 0. What's a tenth bigger than 0? What's 0 plus 0.1? 0.1. Okay. Then you'll subtract. What's 0 minus 0.1? 0 minus 0.1. What is that? That's negative 0.1. Go to your denominator, type the same x values in. 0.1 minus a negative 0.1. What do you get? 3. So the instantaneous rate of change at 0 is 3. I'm going to say I0. That's for the IROC. Is 3 at 0. Okay, let's do the same thing. I'm just going to copy and paste mine. It'll make it easier. But this time, instead of doing it at 0, what values am I looking at now? 1. So it's 1.1. And then what's 1 minus 0.1 going to equal? 1 minus 0.1 would be 0.9. And the denominator, it's now 1.1 minus 0.9. And this would not be I0. This would now be I1. The IROC at 1 is 5. Okay, which one has a greater instantaneous rate of change? I1 has a greater rate of change. The instantaneous rate of change at 1 is 5. The instantaneous rate of change at 0 is 3. Y equals 3x. What was that y value? Sorry. F1 of 0 is negative 4. So here's the first line. Just showing you. There's the instantaneous rate of change right there at 0. And now I'm going to do another line. Y equals 5x minus 1. And I need to know what F1 is. 0. Perfect. Here's my second line. So here's, whoops, come on, click here. There it is. There's the instantaneous rate of change there, and here's the purple coming through. Let me zoom out a little bit more so you can see those better. Which one's more steep, the blue line or the purple line? Purple. Both are instantaneous rate of changes. Notice it's increasing. It's increasing from blue to purple. Because it's increasing, we could say that this has to be concave. Because the slope increases, it has to be concave up. Now that was a whole lot, was it not? But it was a whole lot of the same thing over and over. If you were to boil it all down, what are the two things we learned about today?
Tangent lines and
I hear secant lines, tangent lines. Secant line takes what type of rate of change? Average. Tangent line takes what type? Instantaneous. Okay, if you were to sum up the whole lesson, change of x's divided by change of y's, or change of y's divided by change of x's. Change of y's divided by change of x's. Today, for instantaneous, what we did is we just made the interval really large or really small. Which one was instantaneous? Small, 1/10 is what we did. If you were going to do a tangent line, a secant line, your interval would be larger, 1 unit or bigger. That's what we would do. All right.
What's the answer to this question?
Oh, the answer would be, which one has a greater instantaneous rate of change?
I1.
The instantaneous rate of change at when x equals 1, which is greater. What in the world? Trying to combine is and greater. Is greater than IROC equals 3 at x equals 0. And that would be your answer on that one.